Welcome back, my dear student. This is the physics lesson and we are going to continue the same chapter we are doing that was about the forces. Now we are going to start the new topic that is regarding the elastic objects. First of all, going to start the topic, we just want to revise whatever we have studied. We studied about the force. We studied that force can change the shape of the object. The force can change the size of the object. The force can change the speed of the object, and the force can change the direction of the object. We will continue from the same thing. For example, the first thing we said that the force can change the shape or size of the object. So according to that, it means if you are going to apply a force on an object, it will change its shape. But on the other hand, if you will remove the force, the object will go back to its original shape or not. It is different in different cases. When you apply a force on an object and the object will go some kind of change, and if you remove that force and the object will come back to its original shape, this type of object is known as elastic object. So if you want to define what are the elastic materials, so you can say elastic materials are the objects which change their shape when a force is exerted on them. And at the same time, if you will remove that force, those objects will go back to their original shape. The examples in your daily life is given. They are spring, rubber band, balloon, and I had some pictures for you. Hopefully you are using all these things in your daily life. So if when you are applying the force on them, so they are changing their shape. When you are going to remove the force, again they are going back to their original shape. Now let's move to the next thing, that is Hooke's law. Actually, the Hooke's law is based on this fact that when you are going to apply a force on elastic material, they change their shape. Now, for example, they're saying the stretching force is directly proportional to the extension if elastic limit is not exceeded. So we'll see the first part of this law. For example, here, once again, okay, if you see this one, stretching force means the force which you are applying on the elastic object is directly proportional to the extension. If you see directly proportional, this is a kind of relationship that if you have two quantities, if you increase one quantity, other will also increase, or other case, if you decrease one quantity, other will also decrease. So this type of relationship is known as directly proportional. After that, they talk about extension. What is extension? From the word, you can say extend, from extension, extended, all these are same meaning. Extension means increase in size. This increase in size can be increase in length, it can be increase in width, or overall it can be increase in volume. So according to this law, the stretching force is directly proportional to the extension. If we want to write this law in a mathematical form, so it will be this which I highlighted for you. What is that? Stretching force, this red sign is sign for proportionality. And it shows here stretching force is directly proportional to the extension. Sometime instead of stretching force, they will use only force. So it's the same thing. And sometime instead of the force, they will use weight, because weight is also a force. So if you want to write this equation in the form of symbols, so you can write for F for force, equal sign. When you are going to remove the sign of proportionality and you want to put equal sign, you have to put a constant, and in this case K is constant, and this K is also known as spring constant. Every spring has its own spring constant. Simply, what is a spring constant? It is a ratio between the force and the extension. If you have two different types of springs, one is made of copper, other is made of iron. Okay, here we are talking about the spring constant. Spring constant means that every object, for example, if you're talking about two springs, one spring is made of copper, let's say other spring made of iron or steel. So you have these two springs made by different material. If you will hang the same amount of mass on both, for example 1 kg here, 1 kg here, they will not give you the same extension. They will give you different extension because due to their material, due to the thickness of the wire which they are made of. So there are a lot of factors. It means that each spring has its own behavior for extension. It expand, you can say it extend on their own, you can say the constant value. So we can say every spring has its own constant. Move to the next part. Now according to the Hooke's law, if the force is applied on object, means elastic object, it will extend or it will be increase in length or size. If you will if you will do the force double, or you can say that you will put double weight or double mass on that object, the extension will be also double. And if you will not apply any force on that elastic material or the elastic object, it means there will be no extension. So again, for your more understanding and comprehension, what is extension? It is the increase in length of a spring when a mass or weight is added. This extension not only for the spring, if you are using the rubber band, it's also there is extension, because when you apply a force on the rubber band, it's also there is an increase in its length. Now if you want to prove this thing experimentally, that okay, I want to see that how the spring is going for extension if I'm going to add some weight or some mass on it. For that you have to do the experiment, and it's also known as experimental verification of Hooke's law. So for that you have to follow a procedure, and in this procedure you will see some steps. For example, what's the first step? You will take a spring and you will take a ruler, and you're going to find the original length. Original length means the length without adding any load, or the length before adding any mass or weight or force, whatever you can say. So now here, what is the original length? 20 millimeter. 20 millimeter. Now if you will add some weight, for example you are going to add 10 grams. Now 10 grams means 0.1 newton. Okay, now here we talk about extension. So how are you going to find the extension? Extension is equal to original length and the length after adding that one. If you are going to subtract them, what is the formula of extension? Length after adding the weight, what is that? 25 millimeter. And what was the original length? 20 millimeters. If you are going to subtract them, so what is the answer? 5 millimeter. This is the extension. Once again, if you want to find the extension, so how you are going to find? First of all, you will take the value of the length before adding any weight. Then you will take the value of the length of the spring after adding the weight. You will subtract both of them and you will get the extension. Okay, now going to the next part, means if you will continue adding more and more masses, so it means that there will be more and more extension. For example, the next one, they added 10 grams more, so total will be 20 grams, and this 20 grams will produce a extension of 10 millimeter. How? For example, now what is the length after adding 20 grams? That is 30 millimeter. In 30 millimeter you have to subtract from original. What was the original? Again 20. And now what will be the answer? That extension length after adding weight, subtract original length. What is that? 30 minus 20 equal to 10 millimeter. I just compiled all these three diagrams again here to just give you like a comparison between all these. For example, if you see the first diagram, there is no extension because there is no load. Second diagram, there is an extension because there is a load there. And the third diagram, there is more extension because there is a more load. So if you will repeat all these experiments up to 50 grams, so then you can record all these things in this table. For example, this table in the first column is used for mass, second for the force, because you can convert mass into force, and then the spring length, and then the extension. For extension you will use the same formula. For example, original 20, each value you will subtract from this 20. For example, 25 minus 20, 5. 30 minus 20, 10. 35 minus 20, this one. Always you have to subtract from the original length. If you want to draw this graph on a graph paper, you can find this one. So here you have two axes. On y-axis you have the force, on x-axis you have the extension, and if you draw the graph, you'll find a straight line. This straight line shows that these two quantities, for example force and extension, they are directly proportional to each other. So this is about the Hooke's law. I hope you understood the lesson, and if you have any question, you can ask after through WhatsApp, or you can write in the comment. I will answer for that. Thank you very much.